Nice to be here. Thanks for having me. My name is Tejas. That is pronounced like advantageous. Advantageous. Whether or not I am advantageous, we'll find out during the course of the talk. And I'd love to speak to you today. I am the Director of Developer Relations at Zata, or Zeta, depending on how you say it. And we love developer experience. There's been some amazing developer experience talks. This will be one of them. And before we move further, though, like a lot of talks end with a thank you slide. I want to start with one of these. Can we just give some love to the people who made this possible? I mean, Michelle, Joss, G2I, come on, JSWORLD, the production crew, the interpreter, oh my word. It's unreal. But like, you see this and you're like, okay, that's cool. Let me show you something. This is what's happening behind the stage. There's like, it's like the Matrix back there. There's like hundreds of computers and switches, and there's people behind the scenes making this possible, and this conference wouldn't work without them. So really thankful for them today. We are here to talk about building a massively scalable and performant Jamstack app in minutes. In fact, so massive it doesn't even fit on the screen. There's a lot of buzzwords here, so I suggest let's just dissect this a little bit and see what we actually mean with this. What do we mean by massively scalable? For the purposes of this talk, I've broken it down a bit, perhaps oversimplified, but I have 20 minutes. I used to work at a company called Spotify, and at any given time, there's about like 300 million or more people listening to music around the world at Spotify. That's what I would consider massive scale. For the purpose of this talk, I've defined scale at 3 levels. I call these the 3 S's of scale within this talk, and those are seed scale. This is, when you're creating a proof of concept, you're just kind of putting stuff together. You want to see, does it work, does it not? You don't really care much about having it be right, but it has to work. You're tracking with that, it's just something that works. Second, I call it startup scale. This is where you have users. You have like 50, 100, maybe more regular users. You can't afford to break stuff anymore. Not only does it need to work, but it needs to be right at this case. And if it doesn't, you're going to have a hard time because your users are probably going to be annoyed at you. And third is substantial scale. And this is kind of the Spotify example I was using earlier. This is where not only does it need to work and be right, but it needs to be fast. And if it's not fast, your users are going to give you a hard time. And to be honest, your engineers as well. I feel like there's engineers who work within these companies who, I'm one of them, who are like, oh, come on, that takes 2 seconds, really? For all intents and purposes within this talk, that is what we mean by massive, or by scale in general. Let's talk about minutes. Building a performant and massively scalable Jamstack app in minutes. So I wanted to clarify minutes here because believe me, I could just build an app here, like live code, demo something, and then slam it with like load tests and have it not break and blow your mind, and you'd be like, wow, that's amazing. And it would make for an amazing demo, and you'll think I'm really smart, but then you leave here like unchanged. You won't really get much value. It may be good for me, it's just a massive flex, but I don't want to be that guy. So we're not going to do that, but instead I want to talk about the thinking that goes into creating something that can, if you experience a spike, that can scale to these levels. That's the goal. So I want to talk about thought process and direction and steering of your products instead of like doing some cool demo and then saying, okay, goodbye, great conference. All right. So with that, let's identify things that Jamstack apps have in common. I say Jamstack here. For those of you who aren't familiar with Jamstack, it's JavaScript that connects to APIs and then renders markup to users. JAM, JavaScript APIs, markup, Jam. Jamstack apps predominantly use React, I would say, because React is the most popular way to build user interfaces on the web. That is not my opinion. That is NPM statistics. And so we will talk about and use React significantly in this talk. Jamstack apps have things in common. Most apps have things in common. For example, routing. Routing is in almost every single Jamstack/React app on the internet, with the exception of like maybe Wordle. I found out the other day Wordle doesn't have routing. But if you're building an app, you probably have some type of terms of service, some type of privacy policy that people usually don't read unless they really want to. You have some other page in addition to your site or your product, and you'd need a router to show you or to have your page render the right route at the right path. Secondly, Jamstack React apps are deployed somewhere. I mean, this is the definition of like seed scale. This is like having it exist somewhere on the web that people can access it. If you don't really have a Jamstack app that people can use if it's not accessible over HTTP or some type of protocol. And then third, almost every Jamstack app on Earth has data. Data is essential. Data is integral. Can you imagine Wordle without words? Data is important. So that's what I want to talk about. I want to look at these three topics that Jamstack apps have in common and consider them at the three stages of scale. So at seed scale, at startup scale, and substantial scale. Does that sound good? You tracking with me? You still awake? Good. I see nods. So with that, let's talk about routing. If I ask you for your Jamstack, your React, your whatever app to solve routing, let's say you're building like a Netflix clone, right? And you're doing it in React. So routing, what would you do? How would you go about this? React, exactly. So people lean towards React Router. It's just, and I've seen teams that want to move fast that will just like reach for something open source. And that's awesome that we have that. Open source is a blessing, but here at React Miami 2022, in a talk about these things like routing, we have a great opportunity to not just pick a library and go with it, but maybe to understand a bit more the complexities that these things solve. This is time here we don't have when we're moving fast and shipping at seed scale. So let's take advantage of it and let's understand it. And I'd like to do that by, let's just create a basic, if I can call it a poor man's React router from scratch, just to understand. So I'm going to exit out of here, and you're going to see I need to duplicate my displays if I can. They didn't know I'd be live coding, did they? But here we are. All right, let's let me do this. See, now you need to play like this Jeopardy music or something. Hang on. I think I got it. Wow, I do not got it. I really do not. Could someone help me with the screen? Sorry. Give it up for your production team, ladies and gentlemen. Woo! So if we can duplicate the displays, I apologize. I should have said that. It was kind of my fault. How are you feeling? Good? Caffeinated? Yes, that was a resounding yes. I had just one coffee today, and I slept like 2 hours last night. But I think, awesome, thank you. Thank you so much. Amazing. Fantastic. All right. I hope that wasn't time spent. Anyway, so it's the last talk. I could go an hour, you still have to be here. Okay, I won't. There's a big clock here, so I know exactly what to ignore. Anyway, router, right. So what we want to do is we have here a folder called lol, and like nothing, just package.json, some config. So we're literally doing this from zero. This won't take a long time. I hope not. And so I'm just creating two files here, index.html, index.tsx. This does use TypeScript. If you don't like that, I apologize. I just prefer TypeScript. And in our HTML, it's an HTML file which will contain a React app, and it needs a root node in which to render the React app. And we'll point this to the TypeScript file that is index.tsx, and we'll tell it it's a module, which it is. We are using this as a module. Then if we go to our index.tsx here, we're just creating a React app. So we'll have a component app. It's a div has a heading, hello, React Miami. All right. And then some energy coming back. I'm into it. We need to render this in our HTML. So I will import create root from React DOM/client. This is the new way to do it in React 18. It is not render, just FYI. And then we'll import React from React, just so that this thing stops yelling at us. All right, now let's render this thing. So we need a renderer. And so we'll create a root with document.getElementById. Root, I think it was called. Let's confirm. Right, it's root. So we'll put our app in there. It does exist. TypeScript, calm down. And we will renderer.render app inside our thing. OK, we have a React app. Does it work, though? I'm using Parcel for this because it's good for demos. Index.html. And OK, 440 milliseconds. That's kind of unbelievable. OK, so it does work. Great, we have a React app. We're trying to implement routing, just to understand, like, just why does everyone choose React Router? So let's try and get that. So what is a router? If you think about it, it's something that gets state, like a DNS name, like a path, and maps that state to a place, conceptually, abstractly, very hand-wavy. That is the essence of a router. So we need some type of context to get the path from. Knowing that, we'll create a router.tsx. This will be a context, so we'll export const router context that literally just creates a context that's exported from React. And it has in itself the current path, an empty string. We will export another one. This is a React component, so we'll just call this one router. It's a function component with children, which is a React node, and with, actually, just that. We'll destructure and get children from props here, and we'll return the router context provider. We'll wrap the children inside. And it's yelling at me because I didn't give it an initial value. So I'll say value is current path. Now, where does current path come from? We'll hold that in state. And this is state across the entire app. So const current path. And we're just using use state here. If you're familiar with React, this is in the tutorial. We'll use state, and we'll use the window location. We're testing out at seed scale just to create a proof of concept, .path name. All right, we have a router context. Now we'll go wrap our app in this thing, so the app becomes context aware. Oops, all right. So now we've kind of wrapped our app in a router. And if you've used React Router, this kind of feels similar. It gives context to your whole app. But now, what's next? We need actual routes. We need to say, hey, at this path, render these components, okay? That calls for another component called route.tsx, why not? And we'll just straight up export const route. It's a function component, same deal. It has children, that's a React node. And we want each route needs to have a path. Okay, so we'll do path, and that's just a string. We'll destructure these from the function's arguments to get props, just like that. And so what does a route component do? If the path prop matches my actual address bar, then show the component. If not, show nothing. So that's what we'll do. We'll return null by default. Fun fact, in German, null means 0. Anyhow, moving on. If the current path, or rather if the path prop equals the current path that is from the browser's address bar, then we'll return the children, and we'll actually render something. I need to import React again. But now look, this doesn't exist. Where do we get this from? Context. So current path will use the router context we just created. So we'll do something like this. And we have a route component. Okay, but does it work? Let's add some links. So we'll create a link. We'll call it test, and we'll pipe, and we'll create another link. I don't know, we'll call it like tweets or something. I'm literally just making this up as I go. And so now we'll use our route component. So we'll say at path test, show, I don't know, lorem ipsum, like this dummy text. And at path tweets, just, I don't know, show my Twitter handle in an H2 or something. If you don't follow me, this is a plug. You really should. Anyway, moving on. /H2. All right. Does it work? So I see 2 links, maybe. Test, okay, tweets. So there, that's a basic seed scale router. It does what you would expect from a router. Now, let's go back to the 3 S's of scale. Does this work? Yeah, kind of. It's okay. Does it work at seed stage? If I was creating a proof of concept, would that be enough? Yeah, I'd say so. Does it work at startup scale? Hell no. You know what I'm saying? Like, it doesn't. It's great, but it falls apart with it doesn't allow server rendering. It doesn't allow path precedence. So if I want to compose paths and intelligently choose the closest match to there's a lot of things missing. And this is why React Router exists. And now we understand that. This is why Reach Router exists. Does it work? And so at startup scale, I would use something like what? Like React Router for server rendering, for path precedence. What about substantial scale? Now, when you're a large company, a large organization, you're going to probably need some type of static site rendering. There was an amazing talk about static site rendering just a few minutes ago. You're going to need something like that. For static rendering, it's not enough to just have a router. You need to have opinionated code. Your app needs some way to know where do I generate pages from. And this is where things like Next.js and Remix come into the picture. And they really help you understand static or SSR or server-side rendering or client-side rendering, and they allow you to switch between them really quickly. So if I was choosing now something for all scale levels, what would I go with? Probably a framework like Remix or Next. By the way, I don't work for any of these companies. I'm not trying to pitch you or sell you anything. These are just open source things that are examples. Okay, I want to be very sensitive to that. Great, so that's routing. We talked about routing at different levels of scale, and if I want to start something and get going in minutes, can I? Yes. Yes, I can either use a framework or an open source library or just write some hack job myself. Deployment, the other concern. Deployment used to be hard, right? And then what happened? Vercel showed up. Netlify showed up. It's this thing where you just like git push and it's live at some like subdomain.vercel.app. Can you imagine? Like, how does that even work? They have edge CDNs where like you, in the case of Netlify. Here, let me show you how easy it would be to deploy this today. I can't help myself. So let's open my lol folder here with my code that I just wrote, this hack job router. This is Netlify. Here. I drag, I drop, and within seconds, I have a site that is deploying, and within seconds more, my site will be deployed to the cloud. Anybody can access it, just here. There you go, boom. My hack job router is now live on Tourmaline narwhal something.netlify.app. Deployment, is it a solved problem on the web? I think for certain static sites and so on, yes. Now, does that work at seed scale? Yeah. Does Netlify or Vercel Cloud, do these things work at startup scale? I know G2I, the organizer of this conference, has some type of love affair with Netlify. Like, I used to work there. Like Netlify and G2, like, their entire thing runs on Netlify, and they're a successful startup. So yeah, it does work at startup scale. It's been proven over and over again. What about substantial scale? If I remember correctly, Kendrick Lamar's store, the e-commerce site, is deployed on Vercel, I think. Yeah, exactly. And so I'd say that's substantial scale. Kendrick Lamar is substantial. I've seen successful apps. I think Apple has something, maybe not Apple, no, but anyway. These platforms do the job. You can reach millions, billions of people using their network. They have content delivery networks that put code really close to the users. And when like a server or a content server is really close to the user geographically, the time to access it becomes faster, as we know. And so compared to like this origin server model, these companies like Vercel and Netlify and Cloudflare make this easier. I think Netlify even yesterday announced, what was it? It was edge functions. So it's running serverless functions on the edge, just like this. It's incredible. We have love here. So we looked at routing at 3 levels of scale in minutes. I think we can. We looked at deployment. I did it in a second. I think we can. And this is not, by the way, this is not to disrespect or oversimplify real problems that companies have at scale, right? But if I was starting something, I know what to reach for. And I know I have a pretty good chance. Let's talk about the third one. Data. Personally, I feel like this has gotten the least amount of love so far in the tech industry. Like I've been part of, look, I've worked at companies with 7 employees. I've worked at companies with 4,000 employees, and I've worked in the middle. And in every single one, I've heard the conversation of, oh, okay, so do we go with MongoDB or Postgres, MySQL, your SQL, our SQL, their SQL, no SQL. And this it just keeps happening. And then at some point you go like, okay, now when do we introduce Redis? Like it's like I'm in Groundhog Day. And so, like here, I want to use narrative to outline what I've seen so far. This is Excalibur, a fantastic tool for what I'm about to do. Usually, if you're at seed scale, you'd start with some type of like, what is happening? You'd start with some type of Postgres. Let's just use Postgres as an example. Postgres is awesome. If you love Postgres, clap once. I said once, but thank you. You'll use Postgres, it's great, and then you have some scale, you have some load, and you scale what? You scale vertically, so you'll throw more RAM at it, you'll throw more disk space, and at some point you've got to scale horizontally, which you can with Postgres, so you'll add like more Postgreses, you'll add like a read replica, maybe more if you're read heavy, which you probably are, you would be. But then it's still slow. As you're a startup, you'll notice, oh, we have 5,000 users, we're still slow. And then guess what conversation comes up? Oh, should we introduce Redis? So let's go with it. So we have a new friend, Redis. Redis holds things in memory, and memory is faster than disk. So Redis, by design, is going to be faster. So what's going to happen now is Redis will talk to Postgres to get data occasionally, but it'll hold a lot in its memory, and then your app will talk to. This is kind of the diagram that's going to happen. But then you grow a bit more. Things are fast, okay, but you need a search engine. And then the conversation is, oh, what do we do? Do we just kind of pay Algolia? But that gets expensive. Not dissing Algolia. You can use Algolia if you want. Chances are, if you're a seed stage startup, you're managing your costs better. And so you maybe introduce something like Elasticsearch, which is hard, but you may do that. And then you'll need to have some type of replication story so that when data goes into your database, that it syncs somehow with Elasticsearch. You'd probably want to use something like Kafka to stream data, so it's written into Postgres, but then goes from Kafka to Elastic. And so then you have some type of consistency. You need to manage connection. This is complex. This is unnecessarily complex for React and front-end developers. You see, if we go back for a second to the slides, Swix had an amazing slide. He had his slide for full stack development. This was a few minutes ago. We're time traveling right now. And this full stack picture, it's fantastic. Look, I'll zoom in a bit. So front-end developers sometimes look like this because the database is just, it's hard. This replication is hard. Sharding is hard. Elasticsearch is hard. Sorry, I'm a bit passionate about this. So that problem is what Zeta solves. Now, I need to tell you, look, I do not do pitches. I do not do sales. I am a developer, okay? So disclaimer, I'm about to talk about the company I work at and the product we build. But you could leave here and not use it for the rest of your life. I do not care, okay? I'm not trying to get you to adopt it. Nobody's going to make a decision in a conference to adopt something anyway. That's not my goal. What I do want to do is give you a peek under the hood and kind of talk you through the thinking that goes into it so that you learn something as a developer at a conference. For me, that's the goal. So is that clear? Is that okay? Do I have permission? Okay. And if you do want to use it, it's free. We don't even have money to gain from this at this point in time. It's a private beta too. So if you go sign up today, we'll be overwhelmed anyway. I have no reason to sell you this anyway. So if we look at Zeta, in a sense, this is kind of what we're doing. This right now is work done by teams over the world, and we don't really want to replace teams. We respect the teams. We do want to honor, though, startups that move fast. We want to give them developer experience that helps them focus on their products and not have to think about hiring a huge team just to maintain this stuff. And so with that, I'd love to show you a little bit about how we're doing that. This is Zata under the hood, kind of oversimplified. So if I go back to my lol folder, let's do some Zata. We'll do Zata init, okay? And it says here, do you want to create a new database? MySQL, your SQL, my dad's SQL, no questions about that. Just, do you want to make a new database? Yes, I'll call the database Miami. Great. The database a schema has been created. So if I go here, there's a new folder, Zata, with a schema. So I have, let's collapse this a bit. Fold, really? Fold, really? Wait, hang on. Fold, there we go. So we have in this schema 2 tables, teams and users. This looks good to me for my app, so I'm going to deploy it. And now it's asking me, do you want to create these tables? Yes, I do. Done. The database exists. Tables exist. I can throw data at it. It works reliably. I can confirm this by visiting the UI. If I visit this UI, at some point, if I reload, it should do its job. And if it doesn't, it would be, there we go. Okay, so let's not entertain the path if it doesn't. Okay, so new database, Miami. And if I click into it, I should see 2 tables, teams and users. They don't have any data, so it's a bit hard to understand what's happening here. I can fix that with Zata random data. Yeah, you best believe. And it's just going to seed this for me now to help me understand what's happening. The email column has emails, as I'd expect. But I'm not sure how this would work in my app. And again, it's all about developer experience. We're not inventing anything new. We're just giving you a premium white glove developer experience around it, okay? Let's say I want users where zip code is greater than 50. This is not realistic. Oh, greater than 60. Okay, I've filtered it down a bit. And now say I want to query this in my app. So I'm going to get a code snippet, JavaScript, fetch, copy, literally browser, DevTools, paste, fetch, and I have the data as I'd expected. This also honors the filters that I set in the UI. So really, what I'm seeing here is what I'm seeing here. As I said, we're about that developer experience, and I can fetch this as much as I want. We take security a bit seriously. I think. Oh no, that's not us. That's Chrome. Anyway, so that's in a sense how we want the developer experience to be with databases. How much time did I just spend talking about, do I need Redis, do I need this, do I need that? None. I also get a search engine out of the box. I won't show you that today because time, which I'm already out of, I apologize, but it's the last talk, so anyway. But what I do want to tell you is Kent C. Dodds this morning made an amazing point. He said, a lot of talks are just about this hype where you get started and go fast, and then they don't tell you how to maintain stuff. And that's the real pain. So with Zeta, we really, getting started is easy, I just showed it to you, but we care about, like, database migrations are the hardest thing for most teams, to do them in a safe way. You don't want to, like, drop your table or column and then break your app. It's really hard. So we care about that too. And this is how you know we care about that. There's this thing. You see that? Our database is branchable, like Git, like Netlify deploy previews. You can literally just like, and so instead of talking, let's just do this. I'm almost done, I promise, maybe. So I will open my schema here, and to users, I want to add another column. So there's a bunch of columns here. I'll add another one. I'll just copy this one, actually. So right next to email, I want to add another column. Let's call it pronouns. My users table isn't as inclusive as I want it to be. And this is a string. So I will actually do these changes in another branch. So I'll check out a branch called pronouns. And this is Git. This is not a new language. So now I've changed my schema. What? Did I save that? OK, I've changed my schema. And now if I do Zata deploy with a changed schema, it says, hey, your database, Miami, doesn't have a branch pronouns. Do you want to make it? Yeah, I do. From which branch is the base? Main. And then it's, do you want to add this column to your branch? Yes. And so it's done. So now if I go here, and I have another branch in the UI, I can just confirm what I just did. And if I go to it, what I'll see is my new effectively a new branch of my database with email and pronouns right there. So we don't share data between branches for privacy and security. Can you imagine if you leaked personally identifiable stuff across branches? We don't do that. But just to verify that this works, I can do random data again, just for the users table in this case. And OK, it looks good. These are not maybe my pronouns, but they are a string. And from a data perspective, it looks like something my app can use. That's the point I'm trying to make. And so the database is branchable that way. And then I can open a merge request. I can have or we call them a migration request. That's unfortunate, isn't it? I can open a migration request, have my team review them, approve them, merge them, so on. Again, OK, let's talk takeaways. We're finished. But I want to tell you, what I showed you is stuff I'm passionate about to help the developer experience with the Jamstack. You don't have to use it. I'm not trying to sell it to you, OK? Takeaways. Takeaway number one, wheels do not need reinvention. I'm happy that I haven't seen a new React routing library in a long time. React Router and the frameworks do an amazing job. You know what that means? That means people who build companies and apps can do the second takeaway, which is focus on their companies and apps. Like if I had 10 hours in a hackathon to build like a Tinder clone, if I spent 6 of the 10 hours choosing a database, I would consider that a huge loss, right? The name of the game has to be, if I'm building like a fantasy football app, I build a fantasy football app. I talk about a fantasy football app. I do not talk about MySQL or your SQL or whoever's. And then the third is iteration is the name of the game. OK, let's do that again. Iteration is the name of the game. So getting started is awesome, but I've seen over my career, companies are as successful as their ability to iterate rapidly. Really. And you know, Next is doing a great job. Vercel is allowing this with the deploy previews quite well, Netlify as well. And we want to do that at the database level to help companies iterate rapidly on data, safely as well, and then evolve as their needs grow over time. And that, I believe, is the way we can actually close the loop and build performant, massively scalable Jamstack applications with React. Hey, thank you so much for coming out to my talk. Appreciate you, OK? Thank you.
Amazing.
All right.